Thank you all for being punctual and arriving on time on this very windy day. A perfect day for talking about wind power. We've got about 20 people in the room right now, and there are more joining every second practically. So we'll get started in 1 or 2 minutes. Thank you very much for joining. This is a Zoom meeting, which is slightly different from a Zoom webinar. A Zoom meeting means that you can see the other people in the room and they can see who you are. If you don't wish to be seen and you don't wish to accidentally be recorded, please turn off your video and change your name so that people don't see who you are. Thank you again for joining us at lunchtime today on the 18th of December. My name is Eric Howard. I'm the Executive Director of the E2 Tech Council. We still have people regularly showing up and then joining the group. So we'll join again and get going in about a minute or two. I'd like to get started. So again, my name is Eric Howard. I'm the Executive Director of the E2 Tech Council. Thank you very much for joining us today on a very windy day in Maine. Some people are not able to join us because they've lost power at their home or business. Happily, the 4 of us who are coordinating the program today do have electricity. So we're happy to be able to join you and talk about offshore wind. I have a few quick slides at the start for some people who may not be fully familiar with the E2 Tech Council. The program is being recorded, and so if you don't wish to have your image accidentally shown, please turn off your video. The E2 Tech Council has been around for 21 years. We have hundreds of member companies, a mailing list of about 4,000, more than 50 different partner organizations, which include government agencies, nonprofits, and other academic institutions and such. The council is actively involved in convening meetings. We're a catalyst for events. We seek to be a credible resource for information, and we seek to connect people both within the state of Maine, as well as connecting Maine to the rest of the United States, to the Atlantic provinces, and other parts of the world. The council is overseen by a board of directors. We just had elections last week for electing some board members for the next 3 years. You can see in different colors our officers, our committee leaders, and our board members. This information, along with their bios, is also available on our website. Some people are curious about our finances. Here's a quick summary. Could also be presented as a pie chart. But about 20% of our revenue relates to these forums and gatherings that we host about 24 times every year. Our next big gathering will be at the Governor Hill Mansion in Augusta on February 1st, when we have a legislative breakfast. About 175 people were at that gathering. We also have a fun gathering down in Biddeford coming up in early January for young professionals. We have 2 new committee chairs for the program committee, Vanessa and Dale. And all of these programs are partially sponsored by Maine Biz, the Maine Technology Institute, and TRC. So I now pass the microphone over to Jeff.
Thanks very much, Eric, and thank you everybody for tuning in. I had not actually remembered exactly how many years old E2 Tech was until Eric, you mentioned it, 21 years, but I was a co-founder of E2 and past president, so I'm pleased to see the attendance today, and I think this may be the largest number of registrants for an E2 Tech Connects event, so it shows the level of interest in the topic and the issues that the state and the country are dealing with right now. So I have the pleasure of introducing Chris Wisseman, who I haven't known 21 years, but it's been probably about 10 or 11 years at this point. And Chris is Chief Executive Officer of Diamond Offshore Wind, which is part of the Mitsubishi Corporation family of companies involved in offshore wind, including Diamond Transmission Corporation and ECHO. Chris has been and still is one of the leaders in the domestic offshore wind industry. He was a founder of Deepwater Wind in 2005, so going back quite a ways, and drove development of the first offshore wind project in the US off of Block Island, Rhode Island, as people know, the 5-turbine project there in state waters. Chris has more than 3 decades of experience developing, building, and financing renewable energy, combined cycle, and energy efficiency projects in the US. And Chris has an engineering degree from one of the Ivy League universities whose presidents did not testify in front of Congress a week or 2 ago, fortunately for Brown University. So with that, Chris, I'm pleased to turn it over to you. And Chris will have some PowerPoint slides to show. And if people have questions, we'll hold the questions until after Chris is finished. And then we'll try to get to as many topics as we can. So Chris, I'll turn it over to you.
Excellent. Well, thank you, Jeff. And thank you, Eric, for inviting me. I am glad to see everybody here. I wasn't quite sure of the protocol of canceling a meeting that is virtual. I didn't have to travel too far to get to the screen here. I'm going to offer a couple of things that may be a little bit more than advertised on the front end. I would like to just spend 5 minutes on context of sort of the offshore wind industry in the US. There's been a lot of news over the past year, and not all of it good, right? There have been a number of project cancellations, really Massachusetts, Connecticut, Rhode Island, New Jersey. And just to underline that although those made the news because they are really, really big projects, it is not just offshore wind that has been canceled. New York, for example, has had just about all of the renewable energy projects that were awarded in 2021 and 2022 or had a similar fate of offshore wind. It was kind of a perfect storm of challenges this past couple of years. It was inflation, it was supply chain, it was sort of overheating of people competing for vessels. I'm going to show you vessels in just a minute, things like that. But I also think that 2024 is the year where there is a huge bounce back. New York is awarding projects as fast as it can to make up for those that got canceled, the reawards. Massachusetts, Rhode Island, and Connecticut are banding together to also start up new solicitations. So there's no abandonment of offshore wind. It's, if anything, it's a doubling down on the need, or really the role of offshore wind fills a role that other renewables can't, in that it is very difficult to let's say, build enough solar to store the power for winter heating. You just can't do that, right? Build enough onshore wind and big transmission lines to bring power into centers of cities. Now, on the positive side, this is the year that some really big projects actually started construction. So I'm going to show you a little bit of what happened. This is what's going on south of Cape Cod. This is the Orion vessel building the Vineyard Wind project. This is actually at the moment driving monopiles. You can see bubble curtains all around it. That is to protect the sound waves from going out and hurting marine mammals. This is a close-up of it transporting these monopiles. So you can see it's a pretty big boat. This is the vessel that's even bigger that was building the South Fork project. This is a project that serves the eastern end of Long Island. This is a really big boat. This is part of what we call the supply chain problem. There aren't that many ships of this size that can build these fixed bottom projects. And so I bring that because what was discovered in this past year is that a lot of the projects that were the reason they were canceled, it was these fixed price contracts and people couldn't account for these gigantic cost increases. And so one of the issues that this brings up is that by and large, the states south of Maine have decided to sort of skip over what the Europeans did, which was start with small projects, learn from those projects, and then go big. A lot of what happened in the US is the big projects were won by European developers, and they, to a certain extent, came in with the mentality, oh, we've done this before, it's old news, we know how to do it, we're just going to do it 3,000 miles west of our other projects. And I think that proved not to be the case. And the reason I bring all this up is it's sort of background, it fits into what the role that the research array plays. And so I'll pivot into talking specifically about the Gulf of Maine and what we're looking at. So here comes, see if I can do this again, 2 times in a row. Okay, so the topic today is the research array, but similarly, I'm going to build it on the foundation of what's going on in the Gulf of Maine. So this is an image of one potential layout of the research array, which is really meant to be the catalyst to help Maine achieve its goals in the right way. So this is a version that shows 10 turbines. Little hard to tell because of the scale on the screen, but these are in front of you. Each turbine is a mile from its nearest neighbor. That's a mile. Gives you some idea on the size of these turbines. So first, I thought I'd get everybody oriented in what's going on in the Gulf of Maine for the bigger picture, the commercial scale project. So the Bureau of Ocean Energy Management controls the leasing, and they're nearing the end of their process to designate potential areas for leasing. And in this image, you can see the green here. This is what the Bureau of Ocean Energy Management has determined are potential areas that could be used for leasing, right? Now they are still to say, and later, early next year, here's a lease area 1, 2, 3, 4, 5. We don't know how many leases there will be exactly, but there will be probably more than 3, less than 10 is a way to say it. So we expect in the first half of the year, they'll have this designation, and then in the 3rd quarter, it looks like there will be an auction for these leases. One of the things that is kind of cool is that BOEM really did listen to commercial fisheries, and up here in the 2nd bullet is, if you notice, these are, the green area starts pretty far offshore. So they listened specifically to the lobster industry and have made sure that the leases they don't encroach upon Lobster Management Area 1, right? So I think that was a big win for the fisheries. Now these sites, even though it's the Gulf of Maine and we all like to claim it, can clearly provide power into Massachusetts. So there's no limitation on what these sites can be used for. Projects could feed anywhere that's economically feasible. So the other sort of timeline thing to look at is the power procurements. Maine law now passed in May and has signed into law, I think it was in July. calls for about 3,000 megawatts of offshore wind procurement starting in 2026. Massachusetts is thinking about it. They have a planning in the works. And generally, for rule of thumb, these past, what I'll call simple projects, the projects I just showed examples of, those on monopiles, have taken about 10 years to enter construction. That's sort of 10 years from the time that they get a power purchase agreement, sometimes a release, before they enter into construction. Example would be those I just showed you, the Sunrise project, the two south of the Cape were from leases that were in 2013. A project that is far south, is kind of out of our awareness, is going up off of Virginia, and it's not even going up yet. They're just starting to receive equipment, was based on a lease that was signed in 2012. So there's just big time lag. Offshore wind projects are not going to pop up like mushrooms. Now, on the last thing I want to show on this figure here is, although these green areas are all far, 40, 50 miles offshore, the research array is a bit closer to shore. It is right in here, and it is roughly 40 miles due east of Portland. So I'm going to pivot into the research array. The overarching goal here is literally, it's a complicated sentence, but this is really it. It's exercise all of the elements of floating offshore wind in the Gulf of Maine at a small scale, but a scale that's big enough to reflect the issues associated with big arrays, to allow the eventual commercial scale projects to be built basically better, faster, and more cost effectively, and with greater appreciation for existing ocean users. And I'll say whether that is human or otherwise, right? We really have no idea, for instance, what the right whales are doing all year, right? We know they're not here in the winter. We don't really know what the spawning grounds are in the summer. So that's part of the research. So this project fills somewhat similar to the role of the UK. The UK is one of the absolute leaders in offshore wind now. And what they did is they did roughly 10, I think it was one that was canceled, 90 megawatt offshore wind projects. So at the time, those were 20, 30 turbines. They learned from those, and then they did round 2, which is a whole bunch of 400 megawatt projects. And now they're in multiple rounds of what we call gigawatt scale projects, 1,000 megawatts at a time. And so really, I'm going to boil it down to these 3 things, right? It's capture the economic benefits. Maine has the ability to absolutely lead this industry, and we call capture it. But that means is build a port to become home to the fabrication, the vast majority of the jobs associated with floating offshore wind. But it's also to set the standards to protect fisheries. How are these things to be marked? How are cables to be laid? What is access going to be like to these sites? And basically, C is set the stage for commercial scale projects to be done right. And right is in the eyes of the beholder. Right is really, that is part of the topic of the state's roadmap, and extensive work really last year and the year before with workshops and getting lots of opinions about what offshore wind done right means, right? And to some, it means don't do it here at all, right? At the other end of the spectrum is making sure that these big leases that are going to be let do not become literally off limits to fisheries. So this requires, really, this last bullet here, research across the spectrum. And I say spectrum because it's ecological, it's technical, it's sociological. It's down to, whales, birds, what kind of mooring types can be more hospitable to fisheries? What methods of building is going to be used? What are the allowances for fisheries? Can you lobster right up close and personal, or do you have to stay away? And then there's like really practical things like working out curtailments with the Department of Defense, right? So there are vessels built out of Bath and Portsmouth that go out and test runs, and the Department of Defense wants all offshore wind turbines shut off when they're doing a test run to make sure that there is no radar interference whatsoever. Right now, there's no limits on that. So that's one of the roles of something like the research array, is to give everybody the ability to sort of get, I'll call it up close and personal. What is it like to really operate around one of these? So the pieces of the research array are really coming together. The BOEM lease is progressing pretty substantially. So this is a close-up of the area that I showed a little bit earlier. There were a lot of hurdles to be overcome. These are really administrative hurdles that are in law at the federal level. So BOEM had to determine that there was no legitimate competitive interest in a research project. There's still ongoing siting resolution with the Coast Guard. The Coast Guard is in the middle of like considering whether they extend these shipping lanes. They kind of function as the in and outward bound separators. They had to complete an environmental assessment and then ultimately come up with a pretty custom lease because it's a research array. It's not a typical commercial project. And so that lease is expected to settle down and be executed sometime in the first half of the year. And so the next two pillars are really the power purchase agreement and the port. Unfortunately, I can't talk about the power purchase agreement because it is part of an ongoing negotiation with the Public Utility Commission. But I do want to show you a bit about the port. Port is really also progressing. So the Department of Transportation has been working on with the advisory group on sketching out how a port could be built, where it could be built, what its functions are. But I will sort of simplify this and say that a floating offshore wind port has to handle these four features. Foundation fabrication. So we're anticipating that the University of Maine's concrete foundation will become the foundation of choice for all projects built in the Gulf of Maine. And why do I say that? One is because I'm very encouraged about the cost of building with concrete versus steel. And the second element is because it is concrete, it can be built locally. It requires a port, but there really isn't the steel industry of the scale that is necessary for floating offshore wind in Maine, frankly, on the East Coast, frankly, even the United States. So for this to have a meaningful economic impact, positive economic impact, it really is a technology that should be embracing University of Maine foundations and something that we can build locally because it is a lot of jobs. I won't go into all the jobs, but it is a couple thousand jobs to set up a manufacturing facility to build these foundations. They are huge. I'll show pictures in a minute and just narrate a little bit. But then you also build these gigantic foundations on land. You have to get them in the drink, right? So there are an integral part of building the port is a method to get them from land into the water and floating. You also need to be able to receive all of these components. The wind turbines themselves, the blades are more than a football field long, just one blade. And so it takes a lot of laydown area. You need to be able to have ships come in and offload and store them on site. And then the last thing you need to do is you've got your floating wind turbine. Now you need to erect, you got your floating foundation, didn't say that right. Now you've got to erect your tower pieces and the components of the turbine on top. And that requires a really big crane. Show one of those in a minute too. So all together, accommodating these multiple function requires a port of about 100 acres. Now that's for a commercial scale project. There is no port on the East Coast that can accommodate these functions. All the projects on the East Coast, I'll give you a snapshot of projects on the East Coast because there's a lot of ports on the East Coast that are either already operating. These two at the bottom, New London and New Bedford, are already operating, accommodating. Literally, if you drive down there, you can see offshore wind components today. You can even see these out the window from the train if anybody takes the Amtrak south. And so all of the ports south of here are just serving the staging area component that I spoke of. So you can see these up here. These are blades, and you can see that just blades for a handful of turbines take up a lot of real estate. This depiction here, this is a port that's not built yet. is got blades, monopiles, and towers. And the monopiles themselves weigh 1,000 tons, and they require extensive cranes just to move them around on site. So it requires a lot of real estate to be able to move these things around and then prepare them to be installed offshore. The function of the port is to take them off of freighters, right? Unpack them, and then ship them out onto put them on the installation vessels so that they can be installed one at a time. So the other thing that we are working on extensively is how to build a floating offshore wind project. Now, you would think that sounds a little bit silly, but the reality is there are no floating offshore wind projects that have been built at what we call serial production. They've all been like, the original Model T, one built at a time, hand built. And so one of the things that we are doing with the research array is building either 10 or 12 units, looks like 10 now, which is enough to be able to start building an assembly line. And so what you see up here is just one concept of, and I know it's probably pretty small on your all screens, right? But putting basically all of these concrete cast components together, you start to assemble them on a rail system and then bring them to the water's edge. One of the big issues that is being contemplated, you can see here, it's a little hard to explain this, is one of the ideas is building these so that they can be launched on an old-fashioned ramp, kind of like we built ships in the 1800s. You would build the ship, you'd have it tied up, you'd have it on rollers, and then you'd drop it into the drink all at once. That's one concept. Another that's being worked on is pulling up a barge right adjacent to the port, and then the foundation would be shipped onto the barge, called a semi-submersible barge. Then the barge sinks and it allows the foundation to float. Okay, that sounds really cool, but there's no vessels big enough to do that. So those are all being contemplated or kind of around the world. We're working with this real time with a lot of our European counterparts. So the other thing that we're doing is, because we're grappling with this issue, is will the port be fully or partially developed by the time the research array is ready to be built? And so we're also contemplating things like coming up with a way of putting these taller pieces, the tops of the tower, the blades, and the nacelle, erecting those using this is a little hard to see. I wish I had a full big screen and was in a room with you all. But this is a ship, pretty big ship, 200-foot ship, that has these very long legs. And so if we don't have a crane on shore at the port, one idea is, well, we bring the crane to the floating foundation just offshore. So this would be in kind of relatively shallow protected waters. And we would use this crane on top to lift the wind turbine components on. And then once the entire unit is assembled, you tow it out into the ocean to its eventual home. There's a lot here. So the other thing that we're working on pretty extensively is defining the project, right? Now that also is, this is a research project. So one of the things we're grappling with, we don't want to build with turbines that are smaller than those that will be eventually used. So we're dealing with turbines that are getting bigger every year. The turbines that are being built on foundations, fixed bottom foundations south of here in Europe right now are kind of this 14, 15 megawatt class. There are turbines on the drawing boards that are 20 megawatts. So we are going to be building the research array with the then available turbines somewhere in that range. We're doing a lot of work with the University of Maine. Habib Dagger, a dear friend, is in continuous refinement to optimize the foundation. And a lot of what we're doing is what I just showed a minute ago, is these sort of manufacturing layouts. Are there ways to design the foundation to optimize for constructability? constructability being code for how can you make them cost less, right? So we're trying to make this as cost effective as possible. And then the other thing that we're working on is grid interconnection, right? This is a little bit more detailed depiction of where the project would be located and possible routes to shore or routes to shore, not only shore, but routes to electric substations that exist. And what we're trying to do is find routes that allow the cable to be fully buried over the entire route so that once buried, they're not obstacles at all to fishing. Again, it was one of those lessons learned from an earlier project. You know, there were no issues going out with the cable out to Vinyl Haven until it worked its way to the surface and started getting cut. Now that cable's all buried. There was a cable buried across Long Island Sound where they tried to have some of the cable basically lay on the seabed that was rock, on a rock outcropping, and then that creates a long-term obstacle for fisheries. Now, at that end of Long Island Sound didn't really matter because pretty much the sound is dead towards New York City. There's no fishing and nothing to be caught. So one of the key things that we're doing in 2024 is we're doing what we call the seabed geological recon survey, right? And this is to be able to find cable routes where we can bury, and then looking at the site itself where we can best bury anchor so that they are not protruding above the surface. So that will be only once this lease area is finally defined, all the resolution with the Coast Guard is complete. So likely next fall, we will have that survey. And it helps define the geometry, right? The foundation, the location of those anchors. Again, if there's outcroppings, you can't put an anchor in one location. If there's deep sediment, you want to put the anchor there. It also goes hand in hand with the ecological surveys. So when surveys are done, kind of like all upriver, you want to make sure that where the cable route is located is in as benign as possible as a location. What we're working on is this last bullet is typically these surveys require a vessel that is kind of the size of a trawler, a small trawler, that tows behind it an array of equipment. And this is equipment to both make sound and capture sound, because it's sound waves that penetrate the bottom that give an indication of what that bottom is made out of, rock or soft silt or hard clay or sand. So what we're trying to do is come up with a vessel. There's technology out there. We're planning on it. I'm not trying to do. We're planning on a vessel that has all of this integrated into the vessel so that we don't have to tow all of this. And the importance for that is it is less disruptive for lobstering. The lobster fisheries do not have to move. There's a lot of trawls that happen offshore each year. NOAA does a trawl. And lobstermen have to move their traps where the vessel is going because they can get caught and hung up on that. We're trying to avoid even that level of inconvenience and come up with a technology that is all integrated in one so that lobstermen don't have to move their traps. Again, that proves out great. That's part of our, I won't call this research because this is sort of practical, but it is one element of research that helps in the future. So I want to show you all, this is a work in progress. This is a simulation that does not reflect a day like today. This is an ideal day where the water is glassy, calm, and it's windy. Never happens, but anyway, that's what our simulation is going to show. This picture that you see on the screen is looking at that wind farm from 3 miles away. So from 3 miles away, they look pretty darn close. And then the video is going to zoom in. You'll be 2 miles away and then 1 mile away, and then it will go into the wind farm. And we plan to do a lot more with this video because you can even look at the underwater architecture, but I just thought I'd give you we're not ready to show the whole thing yet. It actually doesn't show well on the screen, but I want to show you this video because it is really kind of cool. If it actually starts. It might be a little jerky on your screen because of the internet. And we eventually want to do one with real waves. So now this stops at 2 miles away. So remember, these are like 2.5 football fields tall. So that's 1 mile apart for those turbines. So now we're 1 mile away from that turbine there on the left. And then they were sort of zooming in to what it would be like to be on a fishing trawler in amidst this wind farm. And what you see, the main thing you see is there's a lot of space. Although they're really big structures, there's a lot of space in between them all. So that is what I've got for you, what I want to show you today. And I just wanted to open the floor to questions that are being moderated by Jeff, I believe, right?
That's correct. Thank you, Chris. And thank you for that. And we do have questions in the chat. Let me just ask 1 or 2 quick clarifying questions before I dive into the chat. In terms of burying the cable coming ashore, I mean, that's not always 100% possible. Just for people's benefits, if you can't bury the cable in certain places, what does one do then? What's the state of the art?
So the state of the art is to pin them. So let's just say there was a ledge outcropping for, I don't know, a couple hundred feet. So you pin them down so that they can't move, and then you put what are called concrete mattresses on top. And that is a mesh of almost, it's bigger than concrete blocks, concrete preformed pieces that are held together by chain. They sit on top of the cable, and then eventually silt and other stuff fills in so it becomes more looking like the sea bottom.
And next quick question, just on timeline and process. So you've talked about the research array, things that will be happening next year. The Bureau of Ocean Energy Management goal is to have an auction, or at least to designate wind energy areas next year in the Gulf of Maine for grid scale projects, 500 megawatts or so. How do you see, what's the timeline you envision for the research array in parallel or compared with the larger projects?
Yeah, sure. Good question. Jeff, you always put me on the spot preemptively.
Sorry about that.
So we expect that the research array will be in the water in the 2030 to 2031 timeframe, and that commercial scale projects will be about 5 years behind that. So that sort of 10-year process starting in 2026 yields projects that are in the water in 2030, 2035, 2036.
Good. And then we've had some questions in the chat, which I'll start hitting into here. One question is sort of, the UK, United Kingdom, has been a leader on offshore wind. Question was, how did they fund their research? Was it 50-50 government versus the private sector or something else? And was it done at UK universities or private sector firms, to the extent you know?
So it goes back a long time now because they did those more than 10 years ago. So
Correct.
each country did it differently. The UK did a combination. It's a little bit like Maine, where they awarded contracts to sell power. So they got developers to build the projects as pure sort of economic opportunities. And then they grafted research onto those. So they did research in the terms of like permitting, and some of the early things were very, very public, like avian studies, what I can remember. So they grafted research onto the projects. And so I'm going to say that in a little bit different way. If you can imagine what the research array functions is kind of like a laboratory. Now, we don't know, we as developer don't control really what happens in the laboratory. All the researchers will come up with research projects, right? Somebody wants to see exactly how many whales there are, where they spawn, and they would put in sensors all around the area before we build a wind farm, and then for years after the wind farm is built, so they can see what whales did before and after. That would be publicly funded, most likely federally funded here. The UK is different because it's all, they don't have this sort of federal state issue. So generally in the UK and other countries, it was funded by the country.
Right. And just to clarify for some folks too, a lot of the early work done really in the UK and Europe was for fixed bottom projects.
Oh, it was all
they're now over all in 5,000 plus are in the North Sea.
Right.
The floating platforms and anchoring, and we'll get to that in a moment, was primarily started in Maine, Maine, and in 2008 or so, and then moved over to Europe. But so one of the questions in the chat had to do with how much draft is required for floating offshore wind turbines. Some ports are shallow.
Yeah, they are. They are. So like the Panamax is like 28 feet, right? So Portland, the part that's navigable, is somewhere in that frame. So that's part of the design of the foundations, because you can make them bigger and wider and then they can float more. They are less cost effective if you don't have deep draft. So that's part of what's going into the port study. Sears Island versus Mac Point versus Eastport is what's deeper and can be more cost effective. So ideally, we would want more than the 28 feet. Ideally, it's more like 35 to 40 feet deep.
Right, and I would just also supplement that because people may remember Statoil from Norway, now Equinor. They had a different technology for their platform or stability, the spar, which was much longer. Long concrete tube would have required much deeper water, and that was part of the problem for them where they would deploy it.
That's right. And virtually the only other floating wind farm that consists of like 10 units was using that spar buoy, and it could only be built in a fjord in Norway because it needed 150 foot of water just to build the thing.
Right, and this is a related question from Robert Myers. Semi-submersible platforms take less material, require less port draft, and tow faster. Should we emphasize that form of platform? And that is the technology that Maine and you'll be using, correct?
Yeah, so these are semi-submersible foundations, in that part of it is above the water and part is below the water. So the way the university foundation works is, imagine it's a big hull, and when you first launch it, there's just air inside, right? And when you get it out to deeper water, you fill the hull up about half with water, right? So it's semi-submerged, and that way it can float where it needs to float. It floats high up when it's in protected shallow waters and is just built. And then when you get it further offshore, you partially sink it, and then that becomes, it's like a ballasted vessel, right? It's much more stable because it's got now 5,000 tons of water in it.
You mentioned the port, and so I'm just going to go to this question because it relates to it, which is the port's obviously very important for the array and commercial scale projects. A lot of factors go into choosing a location. Has a port site been chosen? If so, why not? If not, why not? And you can talk about MDOT, but yeah, go ahead, Chris.
Yeah, I'd have to, excuse me, defer to the MDOT because they've been running all of this research in the Port Advisory Group. So I understand that they are finished with their sort of public sessions of the task force. And Jeff, you might even know more than me, in that they are, I guess, to the point where they would announce their decision of what the proper port is sometime in 2024.
Right, during the winter. There's the state has a port advisory group, and I think just for people's benefit to clarify, the research array is a state of Maine research array, so it is the applicant to BOEM for the lease. Diamond Offshore Wind, Pine Tree Offshore Wind would be the developer, but for the port, that would be a state run, owned, constructed port. And then the final location for that, or locations, is still TBD in the Searsport area. Chris, there was a question about are boats used to transport equipment to construct offshore oil rigs suitable for use in offshore wind?
Believe it or not, they're too small. So the most of the oil services vessels are only able to be what we call feeder barges that can take equipment out to those bigger vessels that I showed at the beginning. So a lot of the Gulf of Mexico stuff is honestly just too small. And so that bleeds into one of the issues that has sort of led to these cost overruns. In the US, we have something called the Jones Act that requires that vessels that are bringing equipment from port to another vessel offshore, because that vessel's a jackup, it's considered also a port. So all of those have to be built in the US. And so the really big vessels that we showed operating offshore are non-US vessels. So a lot of the early work here building fixed bottom foundations has been trying to accommodate the Jones Act by using feeder barges derived from the oil and gas industry, because they're not big enough alone to be able to do the installations. They don't have the same big cranes and things like that. And that seems a little counterintuitive, but a lot of the very, very big what are called top ends in the oil and gas industry are meant to actually be able to be floated out. They build custom one-off solutions, because those top ends can cost $1 billion just to build one. So they come up with super custom solutions to be able to float those out and drop them on top of jackets and things like that. And some of those are big floating foundations too. Sorry, a bit rambling.
No, that was good. So we've got a couple questions from someone from the Oceanic Network, formerly BNOW, and you touched on the feeder barge issue. There was a question about 10 turbines. That is what is proposed for the research array by the state. But on another question that is asked is, have you been able to have good working relationships with any fishing outfits in the Maine area, or are the relationships only antagonistic?
Oh, good question. A lot of, I will say, good one-on-one discussions. It's way better to go dockside one-on-one than big forums. In big forums, they've been sort of mostly have come off antagonistic. But I do think that offshore wind is not the chief problem for fisheries right now. It is, it is accommodating whales and dealing with things that are bigger than us. I think we've had some really good, like when I started this and I started saying they're not going to pop up like mushrooms, when fisheries came to understand that, one, they're not going to be everywhere, and second, they're not imminent, there's a big sigh of relief, and then people got to understand. So I think there's been a really good collaboration. Honestly, I think there's been a lot of good sessions where the state was doing it over the last 2 years and listening to what fisheries wanted. And I think between the governor signing the moratorium on any offshore wind ever within 3 miles, and then BOA more recently saying not in LMA1, I think that was a big relief valve for fisheries. So I think I honestly we haven't talked much in the last 6 months, because our focus has been mostly on the technical and the Public Utility Commission negotiations.
Right, and related to that, one of the other questions from Oceanic was the status of project financing or higher interest rates slowing down your timetable. And that's part of the various forces that have been going on that have been reported in the newspaper as well and other projects.
Yeah, so I have to think about how to say this as counsel, Jeff. What we're doing with the
we can't get too many details of our negotiations.
Yeah, it's not so much, so interest rates don't so much slow things down as change the price, right? So what we're trying to do, big picture, is avoid or learn from the lessons south of here, where, and I will say all the other states have now learned this lesson as well, which is fixed prices that are absolute cause projects to fail. And so what has been done in New York and Massachusetts is they've come up with accommodations. It's called indexed pricing. So if the cost of steel goes up, project price goes up, cost of steel goes down, the price goes down. Same with copper and labor and other things. And so, yeah, so interest rates are I don't know the interest rates are one of those on the equation in New York. I'm just slightly behind on that.
Right. A different question about, you showed the spacing of 1 mile between the turbines. And the question is, could you discuss the factors that drive or influence the spacing of turbines? And will the research array study the optimal spacing based on turbine size?
Sure, sure. I'm going to just put that back on the screen real quick. This one is kind of useful to talk about. So, so these are what are called 7 turbine diameters apart, which works out to be like just a few feet over a mile apart. And the reason you need to put them far apart, it's the same as why jets in airports can't take off really close after one another. There's a jet wash effect, so that a wind turbine that is downstream of another one, if it's too close, it's getting buffeted by the air spiraling off of that first one, and it damages the wind turbines. And so you can't put them very close. So 7 is about as close as you can get. One of the things that we're trying to do as part of the research array is come up with, although this is pretty wide, is considering whether you can do a what we call a transit lane in between, and maybe make one section of the wind farm 2 miles apart from another section, so that you can see what it's like. Basically, captains can take big vessels up that transit lane and see how that works for them. One of the accommodations of the wind farm south of Cape Cod, where they are all, I'm going to go to that image a moment here. So south of Cape Cod, there are a whole bunch of leases next to each other. And originally, it was each developer was allowed to arrange their turbines however they wanted to. And what that meant is that if you were a fishing boat going up the alley of one wind farm, you could hit the next wind farm and there'd be a wind turbine smack in your way. And so one of the accommodations to fisheries was to make sure that they all had the same grid. So if you started steaming up one, you would be able to go front end to the other. And so what we're considering is that maybe we can duplicate some of that here with a really wide transit lane, so that you can have the bigger ships be comfortable.
So I wanted to ask two quick questions, but things that haven't really come up. One is relating to the how you deal with communities, where you bring the cable ashore. We've talked about the fishing community, but you've got experience with community benefit agreements. Can you talk what's sort of different about those, or how you go about, what the plan is, for example, for the research array in dealing with community benefit agreements?
Yeah, so to some extent, depending on where a cable lands, right? Industrial zone, a lot of they're all over the place, right? Because those cables that are landed on Long Island come across public beaches, and then they go up public roads. Virginia's comes right into the community of Virginia Beach. And so it depends on the community, but in general, if a community is inconvenienced in some way, either during construction or something, the idea is to sit down with the community leaders and say, okay, how can we make up for this inconvenience? Is there a way that we can, contribute money, do education, build playgrounds, come up with something that the community can embrace, so that across the spectrum, it's kind of okay, this is a little bit of a pain, but what you're offering more than accommodates for it. So that's something that will happen over the next couple of years. Once we find out the technical limitations of where cables can and cannot be landed, it would be part of that iterative discussion. Could it be landed here, or here? What would be least inconvenient? Right now, we're in the data gathering phase.
And I mentioned that now that you've been working on offshore wind for a couple decades, but also you've been involved in wearing varying hats in Maine. Maine has been a leader, relatively speaking, nationally on offshore wind policy, legislation, initiatives. But from your perspective now, looking back over those 10 or 12 years, plus you're looking forward the next 10 years, if you could make suggestions to the governor, to the leaders in the legislature, what would you recommend for Maine to do to be even more capable and able to capitalize on offshore wind.
Wow. How much time do we have? Because I gotta pull out my crystal ball first of all, and kind of it's a tough one. I mean, I actually believe that Maine is on the right path, and that other states kind of, in my view, messed up. There should have been many more smaller projects that would allow the supply chain to grow organically, right? So when you have small projects, then the installation contract could be $50 million, right? The port upgrade can be $20 million. It's things that I would say normal companies can deal with. When you go to these mega projects right out of the box, every little step costs $500 million. And so what you do is you end up cutting out smaller contractors, maybe even domestic contractors are cut out altogether. So I think what Maine is doing is what should be done. Start small, allow the local supply chain, even local labor, to be able to understand how they work on a project, so that then as it becomes bigger, they can say, okay, I understand it. I just need to do what I did last time bigger, rather than having all these question marks around it. So I would encourage a couple things. I think, and I know we don't have too much time, but one of the things that has been greatly lacking, that was very successful in Europe, particularly in Germany and that side of the North Sea, was what they call coordinated transmission, where transmission systems were built out into the water first, and you could plug in any size wind farm, 300 megawatts, 400 megawatts, 200 megawatts. And what that allowed for was much more competition and many more smaller projects. So it wasn't this sort of winner take all that has caused a real problem. When National Grid canceled its projects, Massachusetts, and South, those left huge holes. Now, if that had been a 300 or 400 megawatt project, you'd still have two more that are going. So I think that's going to be my counseling is, hey, realize that starting small actually yields a better result in the end.
And I know we're heading to 1 o'clock, and Eric is going to have some closing remarks. So just quickly, question on the expected lifetime of the turbines, and any plan for life cycle maintenance, disposal, et cetera.
Yeah, so they are nameplate set up to last 25 years. It is a question of whether they indeed, some of the early wind farms are expected to last longer now because they're engineering estimates. There haven't really been wind farms up for 25 years. There was one that was decommissioned that was smaller turbines, it almost doesn't really count. So they plan to last for 25 years. There's things and parts that last a lot longer. The cables typically last 50 years or more, so you can reuse those. So when you rebuild wind farms for round two, they can be quite a bit more cost effective because they can reuse bits and parts of them.
And Eric, I'm not sure how much more time we have, so I'm asking you. 3 minutes. Okay. Chris, just quickly on the grid, you mentioned that Maine has had a lot of discussion about transmission capacity and everything recently. If we are talking about potentially whether there's an offshore coordinated transmissions or anything else, bringing apart from the array, which is max 144 megawatt nameplate, but what would there need to be changes in the existing transmission system if more power was coming to shore from offshore wind?
So there will need to be changes in the transmission, offshore wind or not. So part of the plan of all the Northeast states is to what I call electrify everything. So that is plugging in your cars, that is heating your house. So all it yields where every state will use between 2 and 3 times as much electricity as it does now. And so there will need to be electric transmission upgrades kind of everywhere. And the question is where and what. So that's just something that's going to emerge over time. Part of the idea of the coordinated transmission for offshore wind is it would be like connecting Maine Yankee to an offshore wind farm that also connects maybe south of, let's say south of Kittery, because Kittery is where the congestion point is. so that you could have power flow any direction there, and it would solve some of the transmission problems.
So, and again, I'm mindful we're 12:59. So Chris, I want to give you the opportunity for any closing remarks you'd like to give before we turn it over to Eric.
I will yield the floor to Eric. Thank you very much.
All right. Well, thank you, Chris, and thank you, everybody. Eric.
Yes, I especially want to thank Chris. I thought he did an excellent job presenting the information in a way that wasn't full of jargon and acronyms, which sometimes happens with certain presenters. And so it was very clearly done. Thank you so much, Chris. I do know you showed a picture of the facility down in Salem, Massachusetts, which is the old 750 megawatt coal and oil power plant, which was right there on the waterfront because they were bringing in coal, and they've converted it, that 42-acre site, to the wind farm, and they occasionally do tours there. They had about 100 people out there in November showing people what was going on. It's an exciting development for the folks in Essex County, Massachusetts, and it's also an interesting model for us here in Maine to look at what was going on in Massachusetts or further south in terms of these onshore activities that create hundreds of jobs on site for all sorts of different workers, all part of the energy and environment community. I appreciate the 68 people who are still with us at this point. And thank you very much for spending some time with us on this very windy Monday afternoon. Thank you so much.
Thank
Great.
you.
Thank you.
Eric. Thank you all.
Thank you.